best landing of the Airbus A340-300. Preparation and takeoff of Virgin Atlantic Flight 24. On the evening of November 5, 1997, a Virgin Atlantic Airbus A340-300 prepared to depart from Los Angeles bound for London with 98 passengers and 13 crew members. The aircraft, only 4 years old, was one of the most modern Airbus models at the time, designed for long-haul transoceanic flights, featuring sophisticated automatic systems and sensors monitoring nearly every component. The flight crew consisted of Captain Tim Barnby, with over 14,000 flight hours, First Officer Andrew Morley, who had extensive flying experience on other Airbus models but was new to the A340, and Relief Pilot Craig Maton, ready to take over during the journey to allow the primary pilots to rest. Preparation procedures were carried out sequentially. Final technical checks, full fueling, and ensuring all aircraft equipment was operating normally. As the clock neared 9 p.m., the plane was pushed back from the gate. Its 4 engines roared and began to taxi to runway 24L. The departure route headed towards the Pacific, then turned northeast, beginning a journey of over 10 hours to London. In the cockpit, the captain focused on communications and paperwork while the first officer controlled the aircraft. Immediately after the plane accelerated and left the ground, everything in the cabin was normal, but the seemingly routine action of raising the landing gear initiated a chain of events that would push the flight into a critical situation. Every action was technically precise, yet no one in the crew realized that a small mechanical detail was malfunctioning, enough to change the entire course of the flight. Step by step, from focus checks, engine start, taxiing, and takeoff, the operations seemed normal but were performed in a context demanding absolute precision, setting the stage for subsequent incidents. The meticulous preparation and crew experience were the only factors keeping the flight under control before the technical failure appeared. The landing gear malfunction of Flight 24. Just minutes after lifting off the ground, a seemingly minor mechanical detail began to shape the entire course of the flight. When the captain commanded the gear retraction, the left landing gear did not operate normally. The cause was a crucial pin in the mechanical structure that had slipped out and fallen, preventing the gear from fully retracting in the cockpit. All procedures were still followed correctly. The signal from the left gear's brake sensor only showed 2 X marks, a signal loss warning. For a crew familiar with a multitude of technical signals, this was an abnormality, but initially not enough to cause alarm. The aircraft continued to climb, the autopilot was engaged, and the journey proceeded northeast towards the Atlantic as planned. The crew continued to monitor the control panel, checking indicators and system status. However, the real issue was not the sensor but a physical failure in the left landing gear mechanism, a detail the pilots could not see from the cockpit. During this time, the aircraft was still operating normally, with electronic systems continuously relaying data from hundreds of sensors. All indications suggested the flight was stable, preventing the crew from realizing the severity of the situation. This was a delicate moment. A small but significant mechanical error had silently placed the entire aircraft at risk, ready to manifest during the landing preparation. This incident clearly demonstrated that in aviation, seemingly trivial details can become the starting point for a complex chain of events, requiring absolute vigilance and coordination between the crew and the ground. Difficulty lowering the gear at Heathrow. As Flight 24 began its approach to London Heathrow, the technical situation began to clarify. The left landing gear still failed to extend, causing the aircraft system to issue continuous emergency warnings. The gear unsafe signal appeared on the main display, along with numerous related warnings on the ECAM system, forcing the crew to halt all secondary tasks and focus on handling the issue.
Gear unsafe.
Standard procedures for gear extension, which had been practiced in simulations, were quickly attempted. The pilots attempted to lower the gear using gravity, a procedure designed to solve hydraulic failures, but the result was unchanged. They proceeded to reset the circuit breakers related to the gear system, aiming to rule out an electrical fault, but this also had no effect. These actions were performed step by step, in a strict sequence, to avoid creating new problems for the system. With each passing minute, the crew realized that the issue was not a sensor or a false signal, but a genuinely stuck mechanical mechanism. Meanwhile, the aircraft needed to maintain a stable altitude, speed, and flight path to continue testing emergency measures. Every decision was carefully considered, as a small mistake could turn the Airbus A340 into a danger to the airport and those on board. The struggle with the technology was prolonged, but also demonstrated the importance of coordination between the crew and ground support. Approaching the problem correctly, sequentially, and under control, albeit slowly, was the key to preparing for the next steps in the emergency situation. Ground consultation and innovative approach plan. When standard measures failed to resolve the issue, the Flight 24 crew began receiving guidance from the ground. Continuous contact was maintained with Airbus engineers, A340 fleet managers, and the Virgin Atlantic operations team to find unconventional solutions. These instructions were not in the training manuals. Every maneuver was based on practical experience, technical data, and safe operational capability. Point one of the proposed options was to try creating a mechanical impulse for the stuck gear. The crew would slightly lower the right gear, creating a bump force onto the left gear, hoping this impact would help the jammed mechanism to release itself. If this method failed, another measure was proposed. Using G-force midair by subtly changing the aircraft's altitude and speed, leveraging gravity to aid the gear extension process. Every maneuver was calculated with caution. Speed, altitude, and bank angle were strictly controlled to avoid causing further mechanical damage or aerodynamic instability. The crew continuously reported data on the gear system and warning signals, cross-referencing with instructions from the ground. This process emphasized the importance of coordination between the pilots and the technical team, as well as the ability to adapt in unprecedented situations. Creative yet controlled maneuvers became a vital factor, laying the groundwork for subsequent decisions to ensure a safe landing at Heathrow. Preparation for emergency landing. After multiple trials and unconventional maneuvers, the Flight 24 crew decided to execute an emergency landing at Heathrow Airport. The steps were meticulously calculated, from selecting runway 27L to avoid approaching near the terminals, to the method of landing the aircraft on the right gear. This landing technique allowed the aircraft to maintain control even with the left gear still stuck, reducing the risk of losing control upon touchdown. During the approach, the pilots gradually reduced engine power to maintain sufficient speed and preserve aerodynamic stability. They carefully considered every maneuver, from the aircraft's bank angle, rate of descent, to the hydraulic system's reaction, to avoid further damage to the operational gear. Each step was continuously checked and adjusted based on signals from the ground, information from the warning system, and sensor data from the aircraft. The decision to use the right gear alone was not just a temporary fix, but a safety measure calculated based on physics principles and the aircraft's load-bearing capacity. The crew coordinated closely with air traffic control and the ground technical team, ensuring the entire process took place within maximum safety limits. This landing plan reflected a reality in aviation. When mechanical systems fail, the ability to innovatively adapt, coordinate with technical data, and adhere to strict flight discipline are vital factors for protecting both the aircraft and the passengers. Successful landing and passenger evacuation. The Virgin Atlantic Airbus A340-300 Flight 24 landed at Heathrow in an emergency state, with every technical detail meticulously controlled until the final second. Since the left gear could not be lowered, Captain Tim Barnby used the method of landing on the right gear, maintaining control and stable speed for the aircraft to safely touch down on runway 27L. The wings scraped the runway surface, the engine lightly impacted, and tires blew out, but all 114 people on board remained under control. Immediately after the wheels touched down, the crew coordinated closely with the fire department and airport control to implement the emergency evacuation procedure. Passengers and crew were moved out within 3 minutes, with absolutely no injuries. The entire process occurred with high discipline, demonstrating the effectiveness of emergency training and preparation for all scenarios. The event was later analyzed in detail by Airbus and aviation safety agencies. The landing method used by Captain Barnby, landing on the operational gear, minimizing risk to the fuselage and passengers, was acknowledged and officially integrated into the emergency handling procedures for the A340 series. The incident became a clear testament. Even when mechanical systems fail, the ability to react correctly at the right moment, coordinate technical data, and the crew's skillful control can turn a risk into an absolutely safe success. This was a vivid lesson for the aviation industry on how to manage in-flight technical crises. Cause and improvements after the incident. The technical investigation following the Virgin Atlantic Flight 24 incident identified the source of the problem as a pin in the left landing gear assembly. This pin slipped and was subjected to loads exceeding its design capacity, causing the gear mechanism to jam, preventing its standard extension. Although rare, the failure showed that even seemingly small parts can pose serious risks when subjected to unexpected forces. Airbus quickly responded, redesigning the related component to ensure better load-bearing capacity, while also reinforcing safety mechanisms to prevent gear jamming. The operational checklist was also improved, adding more detailed inspection steps for emergency situations to help the crew detect and promptly address system malfunctions. This event emphasized the importance of technical feedback and risk management procedures. It not only protected passengers and crew, but also raised safety standards industry-wide. Every improved A340 is now equipped with the ability